read the question. I'll give some 2 minutes time. Huh? The problem you have to solve it in. You should take help of some basic concept here, no, rather than fighting with the thing. First, it is projected. A small ball is projected from point P on floor towards a wall. It is the wall when its velocity is horizontal. So if there were no wall, it would have completed a path like this. I'll minimize diagram. I to okay, no. You can solve this for 1 hour. You can solve this in very less time. It all depends upon the way you analyze the problem. So it is what I projected a ball from this. It's going to collide at highest point. Sir, how do you can say, because that was the information given, no? And I'm projecting with a speed u, so it will have ux and uy. I projected the speed u. I'll resolve that ux and uy. And there's a wall. The quotient is same for the two, if the quotient of restriction is same for two collisions. So here it will collide with what speed it will approach? With a speed ux. Then it will rebound with what speed? With a speed eux. Rebound speed. It will rebound with the speed ux. It is at max. Is it okay from this? No. Look at that. If it were elastic collision, shall I say it would have retraced path? If elastic collision, it would have retraced path. Since in elastic collision, so where do it will come and strike? It will strike. This is the point of projection. It will strike somewhere below here. The path of this. So when it's striking, so what should be the vertical component of it? It will be same, no? Earlier. Uy. Then what about horizontal component? Horizontal component will remain same. Here I'll put it. This is before collision. Then it will rebound. Then it's telling it will come like this here. Then when it rebounds, it was approaching with a speed uy. So what should happen? It should rebound with a speed uy. It was approaching the ground with a velocity ux. Then horizontal component will not change. Any reason? Because this is smooth, no? Then finally it will land onto this particular thing. So this is a point A. Let me define like this. Tell me what equations we should write. Is asking quotient of restitution. How to bring that? Because we don't have any further information. from where to bring that quotient of restitution? Something, shall we apply collision here? Already we apply, no? It is colliding wall with a speed ux, it will rebound with EUX. It will collide the vertical horizontal ground with a speed UI, it will rebound EUY. Collision concept is what? Something I should take help of now, the projectile motion. And now let's come for, so what is the total horizontal distance as it moves from A to O? First, when it moves from along the path AB, what is the horizontal distance it will cover? AO. That AO shall I write equal to OC plus CA. Agree? That's quite natural, no? AO should be equal to OC plus CA. What is AO? Time taken to move from A to B. UX into time taken to move from A to B. What is OC? OC should be equal to EUX into time taken to move from B to C. What is CA? CA is horizontal component of velocity EUX into time taken to move from C to A. Can you find out this TAB? Half of the time of flight. Half of the time of flight, that should be equal to only UY by G. Then EUX, keep it as. What is TBC? Time taken to descend. How to calculate that one? TBC. That should be equal to only UI by G. I made it, no? UX. Here only along y-axis it will change, no? You should not write E square UX. Huh? Only the component of velocity along line of impact what when will change, no? What is TCA? Time of flight of this? 2UY by G. So UX, UY. Okay, this will be 2. UX, UY by G will get eliminated. So I'll end up with 1 equal to E plus 2E squared. Solve this, you'll get a quadratic equation. You'll get the required answer. The problem has become very simple. Here, due to impact on the y component of velocity change, it will incident with a speed ui, it will rebound with a speed euy. So x component of velocity will not change here. So if you solve this, you'll get answer equal to 1 by 2. So do remember, this is some, I told you, you can do this problem for 1 hour also. The way you think is very important here. So whenever this projectile motion problem comes, no, do take help of that, the distances here. So what is the concept I applied? So let's go back. Some general discussion I'll do it so that it'll be easy for you to manage such numericals. Mr. How on what basis we should think like this? If this is the, I'm making a very generalized discussion. Please do follow. So I'll project a ball with a speed u at t equals 0. If there were no wall, it would have just proceeded like this, no? And let it collide elastically at highest point. So better you resolve this. So it will collide with speed ux. This should have been path, no? If the wall were not there. Then it will rebound with the same speed. Because I am putting equal to 1. So it will retrace path. What is the time taken to move from O to A? And what about this distance? shall I say, half of the range. So TOA is equal to TOA plus TAO should be equal to 2UI by G. And what about this distance OB? OBX to be equal to half of the range. So what is the total horizontal distance traveled by it? OB plus BO. OB plus BO should be equal to range. And now if it is an inelastic collision, just now we have discussed, and I'm making very generalized so that you can analyze problems. It's not that if you do one question, you can manage here. So let's go for general discussion. So I'm projecting with a speed u. So again, ux and uy. So let it collide at highest point, time being. It come and collide. Then if there were no wall, it would have proceeded like this. So here ux, it will rebound with a speed just now we have seen. Can it reach the initial point O? No, it may not reach, no, so it will fall somewhere here. Get in this? So now in this case, what is the total horizontal distance traveled by it? And we know this is r by 2. Is it, this is BC, no, OBC plus BC, will it be equal to range? OB is r by 2. What about BC? BC is less than r by 2. What is the total horizontal distance covered by it? The total horizontal distance covered by the ball should be equal to OB plus BC, no? OB is R by 2. What about BC? BC is less than R by 2. BC is less than R by 2. So with this, what you can say now, horizontal distance will be less than range. Now, instead of this colliding at highest point, let it collide before reaching highest point. Before reaching highest point. So I'll throw the ball. Before reaching highest point, it's going to collide. You can see clearly diagram. Before reaching highest point, so now here it will have u1x and u1y. Let it collide elastically. I think there's a not straight line, no? It's a curve. Oh, everything goes. And now, what can happen here? No, it's a elastic collision. Let me take here. Now, first the first case, let E equal to 1. Now, what will be the trajectory? Since it's having some component of velocity, no. So here v1y, v1x, v1x will be equal to ux. But what happened to v1y will be non-zero, will be less than ui. So because of that, what happened? The particle will rebound and will fall like this. Check the path. So I am projected from point 2 at A before reaching highest point it collide. This is B and C will come now here. What should be the distance OB plus BC? Should be equal to range. And what is the time taken to move from OAC, TOA plus AC? Should be equal to time of flight here because I have an elastic collision. and it will come and strike the ground with the same speed. With what speed you projected, with the same speed, it will come and strike the ground. So what is here? Now OB plus BC should be equal to the horizontal range. If the inelastic collision E between, please do analyze, very important, because you can solve many numericals with this idea. Now before reaching highest point, this is U, Ux. So here it is V1x, V1y. Let me write nearby diagram. Less than 1, less than 0. Now, what will be the trajectory? It will collide, and because of collision, what will happen here? It has become E V1x and E equal to 1, no? So therefore V1x we are writing. What about here in this case? In this case, after collision, it will become E V1x. Now, what can happen to the ball? It all depends on, it may retrace path. So what are the possibilities? It must, what will happen? It must further ascend. It must further ascend. It may strike at these points. So this is A, this is B. And now what are the possibilities, you tell me here now? What are the possibilities? If EV1x is such that it may, what will happen? It may come back here, no? So it may come like this. But it cannot retrace path. Am I right? So it will come like this here. Or if EV1x is a certain value, it may fall beyond the point of projection, or it may fall in front of it. So what are the possible path here? So I'll show 3 paths here. Different colors I'll show it. So another possibility is this one. The first possibility. Vertical height ascended should be same, but horizontal distance can be different. This is one thing. What is next? Another thing. It can happen. Rough diagrams. These are the 3 possible paths there. It may fall in front of point of projection. It may fall beyond, or it may fall at the point of projection. 3 cases will come. But in all the cases, what is the maximum height ascended? Will be same. It depends on y component, and this is how much equal to u square by 2g.
Sir? So the y component after collision will be what, sir?
Will remain same, because the impulse will act along y-axis, no? Along x-axis. Y component will remain as it is. Only x component will change here.
Okay, sir.
Diagram, I'm just so you do get problems, just do make. All these are possible path. These are all possible path. You do have numericals in books, so try to work out few. So the range, what happen? In elastic collision, definitely the range will be the horizontal distance moved by the particle will be less than the range.